Let's go forward with our next presentation. Buzzi. So, welcome Alessandro Rossi. He's been in the group since 2002. He worked in several plants in the field of optimization. Since 2019, he's been a data analyst, and he started the Visual Insight video project, in which BI system and Seeq tools are used. Good morning, everyone. Can you hear me? I wanted to start my presentation by saying that I'm part of a small working group that was just created inside our company. And this group is conducting innovation processes in the field of data acquisition and data management. However, I was a bit upset after Jessica's presentation, saying that 35% of the workforce is basically a burden for most companies, and we must get rid of them, those people who are over 50 years old. Now, I'm about to get there. So, I'm sorry, you'll need a brace with me, but bear with me. But in case I have any difficulties during my explanation, you will understand why. Now, very quickly, this is the company I work for. It became a joint stock company. Here's a little history of the main events. It was created in the area of Casale Monferrato in the province of Alessandria. It is a family business that started from being a cement plant, and then generation after generation it acquired more companies and expanded its horizons. So this is a map that's not very up to date of the several plants all around the world. Now, we are especially in Central Europe, Eastern Europe, Italy, of course, Northern Africa, South America, United States, and Mexico. Here are some of the main figures: around 10,000 employees and 40 million tons of yearly cement production. To better understand what we're going to talk about, first we need to know the four main steps of how you make cement. Many people have issues understanding the difference between cement and concrete. We are dealing with cement. So basically, if you want to make a comparison to understand what cement is, if you take bread and flour, flour is cement and bread is concrete. So in its mix there is also cement together with other things. So to make cement you start from raw materials, most of which are very old. You need to basically shatter these raw materials, so shatter them to obtain what we call flour that you cook to obtain clinker, which is part of the process. So when you put it with water, it reacts. But if you only used clink, you wouldn't be able to give a shape to cement. Now, together with other correctors, you make cement, which can be sold into different forms. This is a scheme of a cement plant, a typical cement plant, we have a continuous process, and normally cement plants have discontinuous productions, but we have a continuous process. So these machines must stop very rarely. They have a high electrical power, also from the point of view of maintenance. They can be quite challenging, so the key is minimizing downtimes. Now let's enter into a more specific field, which is data and our data network. So the core of our system is the PI system. From an IT point of view, the structure is very similar to what a A2A presented, for example. So I'm not going to go too much into detail, but we have different data sources. The most important one is represented by the automation environments of different industries. So we developed this project only in Italy at the moment, so we're talking about 8 cement plants. Each cement plant has a plant history. So electrical schemes and networks are all different from each other. Most of the work we did for the last 2 years was a harmonization of these systems. So we invented a technical scheme, and after exchanging ideas with Imatica consultants and with Seeq consultants, we built something that could be compatible when it comes to data analysis. And we actually obtained very good outcomes. So here are most of the data we have available. And then we have other databases, for example, our management software, or where we store our lab information, which were connected to the PI system in a slightly different way. We also have client tools, which are what the PI system provides us with, and Seeq, of course. Now, this is the same data organization, just with a different view, to highlight that with Seeq, we are able to take information from the PI system and from the PI archive, which structured all the PI points in it with the same relevance. So data research in this archive is not simple. It's not for everyone. You need to have some skills. Average users can find data in asset frameworks. Asset frameworks were built to also meet the needs of normal users who are not, who do not have some technical skills. Data can be organized by section of the plant. Now, if I was in charge of the quality and I didn't have the right skills to look at all these data, it would make more sense to organize an asset framework between materials and products. It's a language that's just more clear for a quality manager, for example. And that's what we've been doing up until now, and that we are still doing. We are going to show you now a couple of examples of Seeq use. And I'm just going to warn you that we spent a long time working on the creation of a structure that could be used by everyone. For the Seeq part, we just limited our activities to reporting, plus some machine learning activities. Here is an example of our reports. So from the automation data from plants, going through PI, we built for a department that manages the maintenance of plants. We built this report. We created it into the Seeq organizer. So for each oven of the plant scheme, the oven is at the center because it's really at the core. It's a thermal machine. As I was saying, we must reduce downtime, so the ovens are really at the center of these schemes. So this report was created with some indices, some information of single ovens, and the report is updated every morning to know how the plants worked in the previous week. This report here has the same data flow. So the source is the automation environment. This is a report coming from a need. Coming from the accountability office, dealing with putting numbers together based on the materials that we use. Now, codified materials don't always respect what happens in the site. So, we have a code, for example, for a certain cave, and if the headquarters needs to know that we produced a certain amount of shale, quality managers need to know the amount of shale for calculating metrics, to have a history of proportions of materials, and to evaluate the consequences. So basically, we looked at two different needs. For cave report and factory reports. So we customized information without changing the anagraphics or anything else. So going back to the cave case, we kept, it's horrible to say that, we kept a parallel accountability. So we didn't generate two different series of data. We started from one series of data and we processed it in two different ways for the specific case. Now, the data structure in AF is fundamental, and as I mentioned, it meets the needs of different structures. This is an example of very important data being reported. We're talking about quality data, so quality data related to products. These numbers here that you see in the trend represent what our clients find in the construction site in the same period. These charts are used quarterly for continuous improvement, and month after month we switched from having Excel worksheets that were changed, of course, by each factory, to having equal reports. So when the CEO goes to a factory, he will find the exact same thing. And really, having the same tool allows you to be more consistent in your reflections. It is evident that updating quarterly such a big volume of data requires many Excel worksheets. So, to have an added value, you should really have the same format. So, quality managers here change the time frame every time. Now, these data that used to be prepared for a meeting of continuous improvement became a daily working tool. So a quality manager now uses these data every day to make corrections every week. Here is an example of data related to a mill producing cement. If I told you that this machine here is the same machine that works here, you would say that's weird because the trends are completely different. Well, this is a very short period of time. And what I just said would be even more evident if I showed you a whole year. Now, what we are looking at is the flow of doses of material in a mill, which are different from week to week because we were making different products. So the capsules you heard about before identify different products, different recipes for materials. So if a milling expert looks at this graph to draw conclusions, they will have some issues. So it will be much easier to take advantage of these capsules to switch to this mode, which we call chain view. Basically, this view filters the time frames where the product I'm not interested in is not there. So we only see the products we are interested in analyzing. So we are going to look at a whole year for one product, and that's something that we wouldn't have been able to do last year, for example. Now, for the future, as you saw, we have the intention to increase the collaboration with Seeq based on their inputs. They do know that sometimes these tools can be only partially used. Now, we attended the training, we organized training courses in all factories, and we started the training saying this training is going to be useless. Because the real training is going to actually occur when someone has a need and they will solve an issue with our help using Seeq. That's the real training. So experience, basically. With Seeq, we are now organizing some regular meetings to understand what we want to do for the future, where we're going, And we are focusing on machine learning projects because really they have an impact on overall efficiency and productivity as well as ROI. Now, if we're talking about saving 6 days of work, changing some Excel sheets, that's not very relevant. But if we're talking about actual evidence ROI, then it's different. We really want to highlight that that's the right way. Now, these are some benefits and results. This is a summary of what we achieved. And I just wanted to underline that the processes we analyzed showed us that using these tools forces you to standardize and harmonize different environments, different contexts, as well as practices. And this is good. It's a very good thing. And having flexibility does not limit any peripheral initiatives. To the contrary, the more colleagues are involved, the more they will have ideas and insights to be applied and to be included. Furthermore, you'll be able to see things that you weren't able to see in the past. That's what someone was saying before. You'll have the possibility to have references about certain indices and to create new ones with further goals.